All right, so looking at page 2 here now from exam 2 from the summer semester. Question 3 asks us, what are the relationship between these molecules? And it says, there's 5 linked pairs, right? So we should have 5 answers. There's a couple ways to approach this problem. You could do it visually, right? You could look for mirror images, right? So if I take a look at this as compared to this guy right here, right? These are mirror images. I could try and manipulate this to see if they overlap, if they, which they won't in this case. But if I have non-superimposable mirror images, right, that would be enantiomers, right? So that would be an enantiomer. And you're like, well, if you say, well, I just don't know about that, I have trouble visualizing this and looking at mirror images and all that kind of stuff, that's fine. Let's do this a different way then. So another way to do this is let's take a look at, right, if we take a look at that carbon, right, and we'll do this and this, okay? So I am identifying, what's the best way of saying this? I'm identifying similar carbons in these two molecules. And what I mean by similar is, if here is where my aldehyde is, right, my purple is directly attached to my yellow, and my green is directly attached to the purple, right? So I'm looking at similar carbons on these related molecules, right? Now this will become important in just a second, but for the moment, if you need to pause and just look at how I identified those or whatever I need to do with that, go for it, okay? So let's take a look at the green. I'm going to just do this for one molecule, and then you guys can pause and take a look if you can do the other ones here. So I'm going to assign priority 1, right, for that OH group, right? I'm looking at the green carbon, so I'm assigning priority to assign chirality, right? So I'm assigning 1 to the hydroxyl group, 2 to here, 3 to there, and then my hydrogen is 4 pointing away, right? Let me just zoom in here on this. So for my purple carbon there, right, I'm making my mental list. My purple carbon is attached to an oxygen, right, this guy right here, right? It's attached to another carbon, right, the yellow carbon right here, right? And then there's another hydrogen, and if we wanted to, right, we could put, right, that list there. Let me just do this in red, right? That's as compared to this carbon in red, which is attached to an oxygen, that guy right there, and then 2 hydrogens, right? So we make our list, and then we can compare the two there, right? Which one's more important, right? They both have a carbon, right? Carbon, there's oxygen. They each have 1 hydrogen, so it comes down to hydrogen versus another carbon right there, okay? So that's how I assign priority 2 versus 3, okay? So I'm just going to try and clean this up a little bit here. Okay, let me zoom back out. So there's my priority. I have my 4 facing away from me already, so this is clockwise. So this is R, okay? And now if I look at, let me erase this now so my numbers don't get in the way, okay? Now I'm going to do the same thing for this guy right there. So let's clean this up. Okay, so we're going to assign priority for this guy here. This is going to be 1. So now this gets tricky, right? My yellow carbon here is going to be 2. Okay? And then this is going to be 3. And the reason for that, let's take a look at my yellow carbon, right? So my carbon in yellow is bound to an oxygen, that guy, and it's bound to the oxygen again, right? With double bonds, remember you count those twice, right? And then the hydrogen here, right, in black. So my green carbon here, my carbon in green is bound once to an oxygen, okay, once to an oxygen. It's bound to this carbon over here, right? So it's bound to another carbon and then a hydrogen also. So carbon, carbon, oxygen, oxygen, hydrogen, hydrogen, those are all the same, so the difference comes down to an oxygen versus a carbon there, okay? So remember with double bonds, they count twice. Cool. All right, just cleaning this up. So back to looking at that purple carbon. So the way we have it numbered right now, right, it appears to be counterclockwise, right? It appears to be counterclockwise. But the 4 is facing towards me here, right? So the apparent rotation is S, the actual rotation is R, right? Remember when the 4 is facing towards you, apparent and actual are swapped, okay? So apparent rotation, right? Apparent rotation looks like it's counterclockwise, but actual rotation is R, right? So this is the RR version. If I look over here, this is S now, and this is going to be S. So what's the relationship between a molecule that is RR and then the SS, right? Those are enantiomers, right? Those are enantiomers, right? So if you swap both of the wedge and the dash, right? We keep the things constant, we swap the wedge and the dash, right? Or we swap two of the groups, whatever you want to think about, right? That's how we get to our enantiomer, right? Non-superimposable mirror image, whatever statement you want to make, right? There's multiple ways to assess these kind of things. But at the end of the day, right, make sure you have the correct assessment. And I'm going to quickly go through here. All right, so we'll do the exact same assessment here. Let me just label these again. All right, so now we can compare this set of carbons down here. So here, this one is R. Here, this one is S. And here, this one is S. Yep, S. And this one's going to be, let's see, R. Okay. Right, so the R turns into the S turns into the R, right? So if you swap, right, so this is another set of enantiomers down here at the bottom. Oops, didn't mean to use that. Okay. Then we look at the other relationships, right? The other relationships, the simple way of looking at it is, right, R here, so that stays the same. R here and S here changes, right? So we swap one of those, right? So these are stereoisomers, right, that are not mirror images, right? Right, these are diastereomers. Same thing over here, diastereomers, right? Cool. And then same thing here in the middle, right? So stereoisomers, which are not mirror images. Okay. So draw the indicated isomer for the following compounds. So we can take the same approach that we have been, and here's what I mean. There's really only two options. You can have this, or we can have that, right? So I drew, right, there's my chiral carbon, right? I need to draw R. We could go through, we could assign first and then go through and do it. And you can, that's fine, right? You can do, there's multiple ways to solve this. In my mind, the easiest thing to do is just draw both options and then just assign which one's R, which one's S, right? So we assign based off of highest atomic number, right, highest Z. So chlorine's going to be 1, fluorine's going to be 2, and then that carbon right there is going to be 3, right? Which means this one right here is 4, right? So if you imagine yourself looking down on this so the 4 is away from you, right? You can see that this is going to be the S version, which means this one here right? That one there is going to be the R version. So this is my R enantiomer there. Okay. So quick recap, all I'm doing is drawing both enantiomers, right? And then just assigning R and S. Okay. Not the only way you can do it, but whichever way is just fine. So I'm going to just get, whoops, didn't mean to do that, delete. Boy, computers do not want to cooperate with me today. Cool, there that is. All right, so we'll do the same thing for the rest of these. Here's my carbons. I needed to draw the R version up here, which would come out like this. And I needed to draw my S down here, which would have come out like this. All right. So there's my R, there's my S. Same thing here. I think this is one we actually did in class, so hopefully you have a little bit more notes about it if you need some more info, but there that one is, okay? The tricky part about here again is, right, the double bonds versus non-double bonds there, right? The importance of those. Assign the IUPAC names. Find the longest continuous chain. So 1, 2, 3, 4, 5, 6, 7. So we got a heptane. Off of my 2 carbon, I've got a methyl, and I've got another methyl off of my 3. So 2, 2, 3. Trimethyl heptane. Cool. Longest continuous chain, lowest locants, right? Here we've got a cyclohexane, and we've got this group coming off of there. All right, so this is sec-butyl. That's a sec-butyl group. You could have also named this as a branched branch, right? So you could have also called this, 1-methyl propyl cyclohexane, right? But either way is just fine. Longest continuous chain. Yes, 1, 2, 3, 3. That's what I wanted. Longest continuous chain. So now we have an ethyl versus our methyls. Don't forget we want to put things alphabetically here. So 4 ethyl, 3, 3 dimethyl. And this is a non-ane. Okay. There it is. Naming rules, right? There's just a set of rules that you just have to know and follow, and there's a lot of them. I don't remember all of them all the time either, but knowing the basics is always going to be important. Okay. And that's that, and we'll wrap this up in the next video then.